Hello, welcome to Chapter 4, where we will be learning how to do experimental design and collecting data. So the first thing we have to talk about is sampling and surveys. So when you have a population of interest, the population is the entire group that you are interested in collecting data from. Now, a sample will be a subset of that population. Now, a good sample is going to be a good representative of what your entire population is. And then the last definition here is census. And what is a census? So you may have heard that recently in the news because every 10 years in the US, they conduct a census of its population, of all the people that live here. And that is when you collect data for the entire population. Now, that is very unrealistic. That's why the US does it so seldomly, is because collecting data from entire population is not only very time consuming, but it costs a lot of money as well. So that's why it is done only every 10 years. All right, so that's going to bring us to our first example, and that is to identify the population and sample in each of the following settings. First one says, you want to know what prospect students thought of the homecoming theme last year. You stand at the entrance to door 30 before school on Friday and poll 100 students. So for this one, what would the population be? What would the sample be? Okay, so for this example, the population is going to be all prospect students because we want to know what prospect students thought. So the population is going to be PHS students. The sample is who you actually gather the information from. So for us, that's going to be the 100 students at door 30. Right, at this point, I would like you to pause the video and try B on your own. All right, so the question said, a politician uses a Twitter poll to find out where his followers agree or whether his followers agree with the recent bill that was passed, and 432 people responded to the poll. The population here would be all of his Twitter followers, and then the sample would be the 432 who responded. All right, and at the bottom of this page, we are going to discuss the 3 steps for a sample survey. So if you wanted to find a sample of people and survey them on something, like do you plan on traveling this winter, what you would have to do is decide what population you want to describe. Do you want to talk about people who live in your town? Do you want to talk about people who go to your school? Do you want to survey your Instagram followers? You have to decide what the population is. Then you want to talk about what you want to measure. So you want to measure how many people said, yes, I plan on traveling this winter break. And then finally, you're going to have to decide how to choose a sample from that population, because usually the population is too big to ask everyone, or to observe everyone. So you want to figure out how are you going to choose a sample from the population. So it is possible to sample badly, and you don't want to sample badly because what that's going to result in is bias. That's going to create bias in your results. So what is bias? Well, bias is when you use a method that's going to favor some outcomes over others. So a statistical study shows bias if it is likely to either overestimate or underestimate the value you want to know. Okay, so I filled that in. I apologize for my writing. It's really hard. Every time I zoom in and out, I think it just makes the video look bad. So I thought, I'm not going to zoom in, and then this is how it looks. So from now on, I will be zooming in to make it look better. But what I wrote here is using a method that favors certain outcomes, and it likely over or underestimates the value you want to know. So you could pause the video and write that down. Again, it's likely to over underestimate the value you want to know, and it uses a method that favors certain outcomes. So here is an AP exam tip. That's what I wanted this to be. So if you're asked to describe how the design of a sample survey leads to bias, you're expected to do these 2 things. Describe how the members of a sample might respond differently from the rest of the population, and then the second one is to explain how this difference would lead to an underestimate or an overestimate. Okay, so for example, if I wanted to know if people prefer action movies versus rom-coms, if I went outside of a theater that just released Die Hard 3 or something like that, I'm going to get the response, most likely, that people prefer action movies. So that is overestimating what I would expect the value to be. If I went and stood outside a private screening of The Notebook, those people are probably going to say, we prefer rom-coms, even though that's not really a com. So I don't know, some sort of Adam Sandler movie, let's say. But that's how I would sample badly, because I'm going outside of a theater that has a certain type of movie. I'm either overestimating or underestimating the value that I'm looking for. Okay, so suppose you were asked to explain how using your statistics class as a sample to estimate the proportion of all high school students who own a graphing calculator could result in bias. So you could respond, this is a convenience sample, which we'll discuss down here, and it would probably include a much higher proportion of students with graphing calculators than in the population at large, because a graphing calculator is required for statistics class. So this method would probably lead to an overestimate of the actual population proportion. So I hope that makes sense. You're outside of a statistics class, or if you ask a stats class, they have to have a graphing calculator. So we're going to overestimate the proportion of high school kids who own one. Okay, so here's the formal definition of convenience sampling. That is when you select individuals from the population who are easy to reach. Again, like my graphing calculator example up here. I want to know high school students, what proportion own a calculator. If I just ask my stats class, that's convenience sampling because you guys are easy to reach. I could just ask you. Another example of this would be you want to know how long students spend on their homework last night, so I would go to the KLC and ask the first 30 students that I see. I just ask them. That's a convenience sampling. All right, next example. Does the following scenario create bias? A survey is conducted at a choir concert asking if funding should be cut from the fine arts program. So do you think this scenario would create bias? What we want to know is, do people, the population, does it believe that funding should be cut from the fine arts? If I go to a choir concert and ask, is this creating bias? Well, yes, this is just like my movie theater example. People at a choir concert probably love the fine arts. Their children are in it, they are in it, their family members are. So of course they're going to say, no, funding should not be cut. So this does create bias. This is a convenience sample. I'm going somewhere where people are easy to reach, and the individuals would most likely oppose budgets. So the value of what I'm trying to find is either overestimated or underestimated in this situation. And in this one, it would be overestimated. I'm going to have a lot of people saying, no, it should not be cut. All right, the next type of bias that you could get from sampling is voluntary response sampling. And what this does is it allows people to choose to be in the sample by responding to a general invitation. I get these a lot through emails, especially if I stay like at a Great Wolf Lodge in Wisconsin Dells with my family. They'll write me back. They'll write me an email and say, hi, Mrs. Pagalco, how was your stay? And then I fill out a survey. That is a voluntary response survey. And the reason that that creates bias is I typically will just ignore those. Who are the people who respond? There are two types. Either people who are extremely happy the place or whatever they're being surveyed about went above and beyond their expectations, or they're extremely, extremely upset. So same thing with Amazon reviews. There's very little, usually people, if it's just like, oh, it's okay, people don't usually take time out of their day to fill out a survey. They either have to be extremely happy or extremely disappointed in whatever it is the survey is about. Right, here's the definition of voluntary response sampling. You could fill that in. So another example of this is voting on the name of a new cub, a wolf cub that was born at Brookfield Zoo. At the time that I typed these notes up, that actually did happen. Like the day before, my children and I went online and we saw, oh, they're naming the wolf cubs. So we went and we voted. If we weren't invested in that, if we didn't care about the wolf cubs, we wouldn't have ever responded. All right, so here's yet another example. An AP statistics teacher was curious about the average grade point average, so the average of their GPAs of students at his schools. He used the 32 students in his second period AP Statistics class as a sample and concluded that the average GPA of students at his school is about a 3.85. What type of sampling did the teacher use, and explain how bias in this sampling method could have affected the results? Well, hopefully you see that if you just ask the people in front of you, that's a convenience sampling method. You're just conveniently asking them. Typically, too, I would think that this is going to overestimate the average GPA. Why? Because students that are in AP classes tend to do better in school than the general public. So again, this is convenient sampling, and it would overestimate the average GPA. If he truly wants to know the average GPA at students at his school, asking a stats class is going to overestimate an AP stats class, because those students that are in AP are usually better students, meaning they get better grades, usually. Okay, so there's the answer written out. If you want to pause the video and jot that down, unless you did it as I was speaking, fantastic. All right, example B. The ABC program Nightline once asked viewers if the United Nations should continue to have their headquarters in the U.S. There was a number to call to vote yes and a different number to call to vote no. Both numbers charged a fee. More than 150,000 people called and 72% said no. They should not continue to have their headquarters in the U.S. So, what type of sampling was used, and explain how bias in this sampling method could have affected the results. You guys go ahead and try this one on your own. Pause the video, and then I'll write in the answer. Okay, hopefully your answer was that this is a voluntary response sample. Only those who felt very strongly would have called in, especially because you're being charged to have your answer be recorded. So people who have to feel very, very strongly for them to actually pick up the phone and call this number, and then this would probably result in an overestimated percentage of no responses. Okay, so now we're going to shift focus on how to sample well. The way that you could sample well is you have to have random sampling. And what this involves is using a chance process to determine which members of the population are included in the sample. So basically, everybody in the population has to have the exact same chance of being chosen to be a part of the sample. Otherwise, it's not random sampling. So if I ask just my AP Stats students, that's not giving everybody in the population the same chance of being asked as you guys. All right, so there's the definition written down. Please copy that into your notes so you have it. So again, it involves a chance process to determine which members of the population are included in the sample. And if it's truly random, everybody should have the same opportunity, the same chance of being chosen. Okay, so simple random sample, SRS, of size, we call it, when we have a sample size, it's lowercase n, is chosen in such a way that every group of n individuals in the population has an equal chance to be selected as the sample. So now there are a couple ways to choose an SRS. The first way we're going to talk about is doing it with technology. And so the first thing you would want to do is to label each individual in the population. Sorry, let me move this. Okay, you're going to label, is the first way. So give each individual in the population a distinct numerical label from 1 to capital N, where N is the total number of people in the population. Then you are going to randomize. You're going to use a random number generator to obtain N different integers from 1 to capital N, so total number in the population, where N, the smaller case, lowercase n, is the sample size. And then you will select. Okay, so now that we've talked about bad sampling methods, we're going to now switch over to how to sample well. So to sample well, you should have random sampling. And what that does is it involves a chance process to determine which members or groups of the population will be included in the sample. So the first one that we're going to talk about is simple random sample, SRS. There's a few different ways to get an SRS. We will talk about them. But if you want the sample size to be lowercase n, so again, that's the size of your sample, it is chosen in such a way that every group of n individuals, so n is the size of the sample, in the population has an equal chance to be selected as the sample. So if I wanted to choose, let's say there's 26 of you in a class, and I wanted to choose 3 of you that I'm going to give a gift card to your favorite restaurant. If I just picked and I said I'm randomly selected and I choose 3 people, you could say, was that random, or did she play favorites and give it to her favorites? And you could accuse me of that, of course. But if I actually choose a simple random sample using technology, or another way we're going to learn is put everybody's name in a hat on equal sized piece of paper, mix it up, and then choose 3 names, you can't say, okay, that wasn't random, typically. So how to choose an SRS with technology is the first way we're going to do it. So you're going to label, you're going to give each person in the population a distinct numerical label from 1 to capital N. Capital N is the size of the population. All right, so if I was going to give each of you a number, I would put little number 1, 2, 3, all the way through 26. Then I'm going to randomize it. So I'm going to use a random number generator to obtain n different integers from 1 to n, where n is the sample size. So in this case, 3 different integers I would have technology give me. And then I'll select the individuals that correspond to the randomly selected integers. The next page here tells you how to do this with your TI calculator, how to randomly generate numbers. So we will do this in class together, but you could read through here and see, because all the button prompts are given to you, what you would press. So you press, if you want to do an SRS, a simple random sample of 10 students from a population of students numbered 1 to 1750. So say this is a big high school and you want to choose 10 kids. It goes through here the steps of how to do that. And then in class on the bottom, how to choose an SRS using Table D. Table D is a table of random numbers that we are going to show you in class how to choose from. All right, that is it for today. Thank you so much for watching. Have a great day.